Good morning and welcome to our webinar on machine learning driven supply chain using Neo4j features. I'm Nathan Greenhood. I'm your host for today and the head of America accounts for Hopsworks. I also have with me Yogesh, who's our head of solutions at Hopsworks. He's going to go into more details about how to scale your AI investment for supply chain using Neo4j features.
Thank you, Nate. Hi, everyone. This is Yogesh Palricha. Just a quick confirmation, Nate. You can see my screen, right?
You are good to go, Yogesh. Thank you.
Okay, great. Welcome everyone. Today, let's go over the agenda for today's webinar. So today we are going to focus on the supply chain use case, how Hopsworks as a platform can really be really help you solve the supply chain management use case. What is the role of the machine learning in this particular use case, and why Hopsworks is really the right platform for solving this problem. We will also get into a quick demo, which will use Hopsworks and a low-code accelerator, which is Infx, and it will show you exactly the steps involved to build this kind of system. At the end, we can take some Q&A. We might take a brief pause in between, and that will you can please shoot the questions, and then Nate and we can coordinate on that one. Okay, so let's understand what is Hopsworks, right? So Hopsworks is an AI ML platform. It's an enterprise platform, which is also called a feature store. It helps you build features on the platform, manage the life cycle of the features, build machine learning models, manage the life cycle of the machine learning models, do the prediction, and so on. So there are like some advantages of building an building your application using a platform like Hopsworks, which we are going to get into. But at the end of the day, our goal is what? Our goal is to create a better AI solution for the business so that they can make benefit of it. Definitely, in the absence of the platform, there are ways to do things, and I'm sure like most of the companies are building their ML models, in isolation, and then kind of bringing all that together through a lot of integration and coding, and that's where we are going to simplify the process, right? So there are like some feedback that we get from customer, like a testimonial. So if you see, there was a top 5 PNC insurance company which actually is using the platform to build their models, and they have built like thousands of models because they have used the platform across multiple use cases across multiple departments. So it's like a single investment they have made into one platform, which is allowing them to leverage all the features of the best feature store that's in the market, and then also get to better accuracy and better performance at the same time. uh, it's a very robust platform. We are going to go through all the features of the platform, which will give you an idea why it is robust. But it's definitely a platform which can scale, like it's unlimited scaling. You can scale as much as we want. It's a horizontal scale technology. Also, you can do cross-region replication and things like that. So that really allows you to be enterprise ready rather than just focusing on building models in your sandbox. So you may still work in your sandboxes, which is okay. But then at the end of the day, all the work that you do will go into the Hopsworks as a platform, which will basically bring the value to the table. Again, there's another head of data engineering of a top 5 retail bank, which is like they want to use a platform. They want a platform which can allow them to build applications and go to the market as soon as possible. Because once you start writing a lot of code in silo, it is very difficult to then go back and integrate and make something which can be robust. So to avoid those issues, like to avoid all the integration consistent from day one, they're not only consistent, but and there are no code accelerators which will allow you to make your life easy in terms of building these applications. So if you are not using Hopsworks as a platform, like today you may be using Jupyter notebooks, you are creating your models, you may receive your data from the enterprise data lake. So everybody is exposed to the enterprise data lake, and then they start building the features within their own sandboxes. And once these features are built, they build their models, and they write a bunch of code, and this code is handed over back to IT. Now IT has to take all of this code and come up with a solution which is more centralized and more manageable, and that is where they really the whole process slows down. So building a model can still be okay in the absence of the Hopsworks as a platform. Maybe it's not scalable. If scale is an issue, then we can take care of that too. But using the platform from day one, a platform like Hopsworks is going to make sure that everybody is getting a consistent view of the feature that they're using, rather than defining the same feature multiple times in multiple sandboxes for multiple applications. So consistency and scalability is still the theme over here. And once you use this platform, then on one single platform you can run multiple use cases. These use cases can use your algorithm, which could be as basic as linear regression. There could be logistic. There could be community detection algorithms, and also you can do Gen AI. You can run your LLM models on the platform itself. So we guarantee you a scalability of your application. That is what Hopsworks is offering you. And also we are giving you a lineage of all the feature development that you're doing. And I'm going to like demo some of these features, which will make it so easy for you to investigate if there is a problem with any of the feature calculation. So just stay tight and we'll go through the demo soon. So what's our goal? Our goal here is again using to build your models. We need to make sure you have a better AI because that's going to help you with better predictions, reduce your cost, reduce fraud if you're doing some kind of fraud use cases, or get a better customer exposure or revenue increase because you may be doing customer analytics using that. And you also want a platform which can really respond in milliseconds. You don't want a model. It's okay to train the model in a few hours. That's fine. And we are going to take care of that problem too because we are a horizontal scale platform, but also you want to be able to do all the predictions in real time. So we have an online and offline feature store, both the features, which allows you to do these predictions in real time, especially for use cases where you want to do a next best offer, or maybe detect fraud in real time, or maybe something where you're doing a credit risk modeling, which we are going to showcase today as a part of supply chain. You also want to make sure that you use a platform that can help you not just ease your life in terms of building models and application and also faster, but also it should reduce your cost, right? So we are keeping all these three aspects in mind. It's not one versus another. What we are really offering you is the best of the three that you can have. So obviously you're going to save more money by using the platform, and that's going to help you build more models, do more experiments, and you can use your money for or your dollars for better use. So as I mentioned, we are a horizontal scale platform. You have an online store, an offline store. This is basically where your features are residing. We do all the compute within the platform, so we kind of scale horizontally. We can also do within Kubernetes cluster if you want to do something more virtual environment. And then we have an API layer which allows you to consume these predictions in integrate these APIs to your platform. Two aspects of the demo today. One is the core science journey takes place, and then we have a low code accelerator which allows you to build all of this and then take actions upon it. Right. Once you make the predictions, you want something which is consumable. You don't want to just write this information or the predictions into some kind of binary file and then let IT struggle like how to consume this output. So as the business users or the data scientists are using the platform, they're going to make life easy by partnering with the IT team at the same time. So it's really a collaborative way of building your applications rather than doing in silo and going into sequences. So there are some benchmarks here. So you can see in the online store, we have 20 million rows per second. That is like 1 millisecond latency. It's really 12x faster than compared to any other competitors out there. We have a link to the benchmark. We can probably share the link later after the webinar. And for the offline, we can do up to like 9x for the read and 7x for the write. So these benchmarks have been done against other feature store or ML platform that are out in the market. So feel free to go to those links and do your research. But I think this is by far the best platform that's available in the market when it comes to feature store or the performance of your model. So this is a high-level view of how the platform will integrate within your enterprise. At the bottom, as you see, we have the platform, the core Hopsworks platform, which is encompassing your feature store, your vector DB, model registry case. So these are all the components you need to use to build an ML platform. Obviously, you can go and start building using open source technologies, but Hopsworks has invested a lot of time to build the best integration of these technologies and make sure you're not compromising on your performance at the same time. So so the platform is the core of it. On the pre-based application that's under the Power Platform, different applications that you can build, like you can use GenA applications, recommendations, supply chain, and so on. So today we are going to focus on the supply chain application, which I'm going to demo you. So let's take a look at it, how you can build a supply chain management system using Hopsworks and Neo4j. So Neo4j is a graph technology, which is basically a graph database where you push your data into the graph database, the raw data, and then you can run the graph algorithms to generate features, and then those features can make it into Hopsworks. So we are going to show you how you can best combine the two technologies together, Hopsworks and Neo4j. And to do all of this, there is a low-code accelerator, which is called Infx, which sits on the top of it to help you orchestrate all of this. So Okay, so let's look at the solution now, which is jointly presented by Hopsworks and Infx. Hopsworks is the ML platform, Infx is the low-code accelerator that I'm talking about. So what's Infx? And let's understand what is the use of Infx, right? So Infx is a low-code application development platform. It's not an ML engine. It integrates to the ML engine, which is Hopsworks, and it also integrates to the graph engine, which is Neo4j. So we are partners with both the company, and the tool actually integrates with all of these systems and make your life very easy. So you can build your application 5 to 10x faster. You can eliminate the need of multiple tools. It gives you all the flavors of data management, business rule engine, workflow management, dashboarding, and building your models, etc. So there are a lot of components that comes out of the box in the low-code accelerator, around like 15 to 20, which I'm going to demo you today, how it can be used to build your applications. Just a very high-level view in terms of how the supply chain management solution is constructed. So there are some steps which we use into this. So there is the first step is really the entity resolution. So entity resolution is an engine that's available out of the box within Infx and Hopsworks, and that's going to allow you to dedupe your customers, addresses, and so on. So every data has got customer, right? I mean, depending upon which industry you deal with, you could have a B2B customer or a B2C customer. In either case, you can use entity resolution to make sure all your entities are unique before you do any kind of analytics. Once we find the unique entities, then we start profiling these entities. We compute all the summaries on a periodic basis. It could be weekly summaries, daily summaries, monthly, and so on. So we keep a track of these entities, like what's going on, and then we run the ML models on the Hopsworks platform using graph algorithms from the Neo4j to basically do the feature engineering and do the predictions in terms of how the behavior is changing. If we find anything, indifferent or anomaly within that behavior, then we are going to score those anomalies depending upon how much, what's the probability, and then, based on that score, we can then put some threshold and generate some alerts. So this is really the action part of it. Like, I mean, you may be building a model which can do the job of prediction, and then once the predictions are done, we can do the scoring. So the alerts are generated, and then once the alerts are generated, then we can do the case investigation. So the alerts are basically the actionable component of the platform where you can take actions on the prediction that are being made. And then you can also do an investigation of these alerts, take a workflow, if you like, some kind of business process workflow, and do like dashboarding and reporting. So the Infx as an accelerator really allows you to build all of these components of your applications just through a no-code idea. The demo application that we built for one of our customers, where we're doing lineage to pull the data in real time and then putting into Neo4j. Neo4j is the centralized store where all the data makes its way into it, and then we run the feature engineering process within the Neo4j. The features are then extracted and sent to the Hopsworks. And once the features are making its way into Hopsworks, we run the ML model we build the ML model, we do the predictions and the whole inference pipeline. So there are three main pipelines that you need to focus on. The first one is the feature pipeline where you are building the features. The second is the training pipeline where you take these features and train different versions of the model. And then you have the inference pipeline where you're going to make these predictions. Once the predictions are made, you can go through the alert engine, which will help you do alerting, run the workflow management, and so on. If you want to block something in real time, a transaction that's happening in the source system, this could be a banking transaction, this could be a transaction like making a payment to a vendor, and so on. So in this particular case, we are looking at what is the impact of like I'm talking about supply chain here. So within supply chain, you have entities like suppliers, which are shippers, and then you have companies, and then you have ports. So if your port goes down, we need to analyze what is the impact on the supplier and on their credit, the credit risk involved with those suppliers. So we are going to build a model which will allow you to basically create the features in Neo4j, push those features in Hopsworks, and then make a prediction that which suppliers are going to default given that a given port goes down. Okay. And then, obviously, once you know that, you can do the alerting and the workflow management depending upon your application requirements. We also have dashboards which allow you to interact with this data. Now, this data can be coming from Neo4j. It can come from Hopsworks. It could be even from a data lake, which may be Snowflake in your case. So you can combine all of this data together, consistently, and then build your features and models using the platform. So this whole orchestration from left to right can be performed using the Infx accelerator. And of course, there are engines which are doing the machine learning part. There are engine which is doing the feature management, like feature engineering, which is Neo4j. And then finally, you have the case management and so on. Okay, so before we dive into the demo, maybe Nate, if you can let me know if there are any questions, we can take them quickly.
Yeah, there's a question on what data sources and also what algorithms that you can use with Hopsworks.
Okay. Um, so in terms of the data sources, we any traditional RDBMS like MySQL, or depending upon whether you're on cloud or on-prem, we have got pretty much coverage for 99% of the databases out there, which are the most popular ones in any enterprise. It's a point-and-click approach where you just select into the drop-down what data sources you want, and then you can connect to those data sources and pull your data. In terms of the algorithms, we have got within the Infx accelerator, we have 40 plus algorithms, which kind of covers the 95% of the use cases. But if you want any algorithm which is available in the open source world, we can quickly integrate that using a small Python script. So we will provide you a template. You can make changes to the template and then integrate within the platform. So it's really an open architecture where you can also write your own code and bring your code onto this platform. It's not really that is going to restrict you by any means. But yes, there are 40 plus algorithms available as of today, everything ranging from linear regression to neural nets and the Gen AI, the LLMs of the world. Any other questions, Nate?
Not at this time, Yogesh. If there's any more, we'll do another checkpoint. Thank you.
Okay, sure. Yeah. So let me switch into the demo now. I'm going to show you the Neo4j piece, and then I'm going to show you the accelerator. That's like, going all the way from bottom up. So you get a good idea of what's happening under the hood. So as mentioned, Hopsworks is a machine learning uh, installation of the Hopsworks. This is where, you can also go and register and build your features and models and so on. So I can click on the features, then I can look at all the features that are available within this. And this is one feature data set that I created today, which is like a supplier feature. We also call it supplier, or you can call it shipper. So we're kind of pulling some information. Some of them could be the real features. Some of them could be just supplementary information. So just because it says features doesn't mean it has to be used into the model. You can also bring in data which you may want to store for drill down purpose or maybe for reporting purpose, or maybe just to take a look at it, right? Like what customers we are talking, which city where they live in. But that may not be a feature within your model as such. The advantage you get is you have your data in one place, and at the same time, you are able to navigate into this data, and then you are also getting the time travel feature as a part of it. So let's say if you're bringing the customer address into the feature store, and for some reason the customer address is changing, every time the new feature data is pushed into Hopsworks, it's keeping a track of it. This is a very important feature which is required into any feature store, which is the time travel, because there could be a situation if you're dealing with a regulatory application, the auditor may come and ask, like, how you made this prediction 3 months ago, and you need exactly the version of the feature 3 months ago that was in production system. So we keep a version tracking of all the feature data that comes into the platform. Also, we keep a version tracking of all the definitions, and also we keep the version tracking of all the models that you have. So you're kind of fully covered from a auditability perspective, and that's why the governance of the platform is really helpful for you. These are all the enterprise features which will be required in any large enterprises or medium enterprise. But they also help the small enterprises to improve their productivity, right? So, so some of the features are here. I mean, there is a label column here, which is the default indicator. So here, what we are doing is we are pulling the data from Neo4j. We are building these features within Neo4j and pumping it into the Hopsworks engine. And there is a label column here, which is basically the default indicator. There are some features which are very specific to Neo4j, like the total cost calculation, where we are using the graph data science library. And also we have a page rank score, which is a page rank algorithm that is being used to identify anything that's influential within the data. So the higher the score, the higher the risk or exposure, you can say. So let's say if a port goes down, there could be a supplier who would have, let's say, a lot of concentration of shipments within that particular port, and then that's going to impact the supplier heavily. So if that supplier is impacted, you want to analyze that, what's going to happen next, right? I mean, what's the reason behind it, and then what's the impact around that? So you can basically look at all the features within the Houseworks platform here. If you want to use an API, you can do that as well. So you can connect to the feature store and you can extract those features using a Python API, or you can use other mechanisms to connect to the feature store into the platform. So going back here, so you have the feature views. And we go back to the home. So your feature groups. So feature groups are nothing but you're grouping all the features. So I may want to arrange my features by customer, by accounts, by transactions, and so on. So depending upon what are your entities, business entities, you can decide how you want to group your features. And then, as I mentioned, time travel and versioning is a part of it. Feature views are nothing but they are like virtual feature groups. You can think like that, where you can take some few features from customer data set and few features from transaction data set and make them together. It just join the two data sets and create a third data set. You can create feature views using the feature groups. We have all the storage connectors. This is the place where you will all the models that have been created so far. It keeps a track of every model that is out there. It has the versioning and the date and time when the model was created. Okay. Right through this UI, if you like, depending upon your permission, you can deploy the model in production, and that's going to basically get deployed in a K-serve environment. So K-serve is a part of the Hopsworks platform, which is used for model development, and that is where you achieve your scalability and performance when it comes to model predictions. Okay. So, so that's pretty much the overview on the Hopsworks. Now I'm going to quickly give a quick overview on this particular application. So, as you see, we have like supply chain data here. There are different type of entities that are available within the data. You have ports, you have shippers, you have packages that are making its way, you have vessels, containers, and so on. So this is basically the graph model or the graph data that has been pushed into Neo4j. And we are going to use this data to do our feature engineering using the graph algorithms and create the features, right? Once the features are created, then we're going to move them into Hopsworks so that you can do the version management, the time travel, the model development, and so on. Okay. So Neo4j is acting like basically a data store, which allows you to build your features. And then obviously Hopsworks is acting more like a feature store, which is dealing with only the features out of that. So, so let's go into the So this is the Infx UI. This is basically the low-code accelerator that I was talking about, which allows you to build your application in a low-code fashion. It has got like more than 15 to 20 different components, which reduces your efforts of integration. It reduces the cost. It comes with inbuilt auditing, Git integration, and so on. So you get all the enterprise features as a part of this. So you can bundle together really the Hopsworks, the Neo4j, and the Infx as a single, as a unified strategy for your enterprise. And then that way you are kind of covered from all aspects, right? In terms of building your apps versus deploying your models and so on. So there are various applications that you can see here, depending upon your access rights. So today we are going to focus on the supply chain management. What I've done is I've created a data set within within this. So there is a supplier feature data set. We can take a look at it. So what we have done is we have connected to the Neo4j system. We have extracted the features out of Neo4j. So these are all the features that I was showing you within Hopsworks. So what you're really seeing is the Hopsworks data using this UI. Okay. So we are more like a UI element on the top of Hopsworks to help you build your applications. So you can look at all the columns that are available. You have default indicator, which is like whether it was a default or not. Obviously, this is fake data. So, but just to give you an idea that you can build your feature data sets right from the UI itself. Okay. So we have a data science module where you can actually build your features. This is the featured feature report, which is created. So let's take a look at it. Let me go to the model. Nate, any other questions?
Yeah, there's a question. So is Hopsworks and Infx open source?
Okay,
Once
well, Hopsworks need, I mean, you want to take that question on the
oh,
Hopsworks and I can do the Infx?
Hopsworks is open source. You can put a link up at the top, and I will put it in again, so you can see the GitHub code. Everything's open source.
Right. And when it comes to Infx, it's a software that is built using the open source technologies, and it comes with its own licensing model for enterprise customers. And we also have a cloud version where you can basically sign up for the Infx platform, and then you can connect to your feature store and the Neo4j database right from the cloud infrastructure. Okay, but it's a per server license, it's a per user license strategy when it comes to leveraging Infx. Okay, so we are looking at the model. So the goal was to create the features. So we have created the features, and the features are stored in the Hopsworks at this point. Now I want to create a model. So I'm going to choose my algorithm, like Python as a library. I can pick whatever algorithm I want. So just to show you what algorithms are available, go into an edit mode here. So these are all the algorithms that are available within Infx platform. You can very well write your Python code and use these open source algorithms right against the Hopsworks platform using the Hopsworks API, which is Python. What we have done is really we have taken those APIs that comes out of Hopsworks and we have integrated them within our platform to make your life easy. So if there are changes on the Hopsworks APIs, you don't have to worry because you are going to do everything in a configurable manner, which is going to generate the code and help you build the model and do the predictions. Okay, so here I'm using gradient boost tree as one of the algorithm. These are all the features that we're talking about. And we have a label column, which is or not. Okay. So once the model is created, then what I can do, I can train this model. So let me hit the model. Okay. So I'm going to go to the supply chain here, supply chain management. And then I'll go to data science and we can take a look at the results of the training. So this is the model that was trained. We can take a look at the results. I just have to give a few seconds here because of the slow internet. Okay. So what we have done is so this model right now is stored within Hopsworks, right? So we have trained the model for you using the Infx platform, stored it back into the Hopsworks feature store. And now you're looking at all the metrics around that model. So like which algorithm was used, how many rows were used. Of course, this is like a sample data that we are using for demo purpose and all the parameters that were used as a part of the model training. I can also look at the features that were used as a part of the model. These are some of the features. Some of them are Neo4j features. Some of them are the raw features coming from the raw data itself. I can look at the performance, so we can show you the confusion matrix, the precision, accuracy, and all of that. Okay, and then you have the train and the test data. So basically what happens is when you configure this model for training, we are taking the data and based on the split you make, like let's say 80-20, we are going to use 80% of the data for training, 20% for test, and then we do the training using that data. And then we keep a track of what data was used as a part of the training itself. Okay, so that's the training process. So then what's the next step really, right? Now what I've showed you is how the features are created and let's look at the lineage part of the feature. So let's say if I'm into the training here, and if there is a question around like, what features are being used and where are the features coming from? So you may want to do a lineage within your enterprise. And we have a data lineage as one of the feature, which is going to show you where is the feature, how it is being calculated. So if you see here, this is the model that we're looking at, which we are trying to train. It contains a feature pod, which is nothing but the feature group within Hopsworks. I can click and jump into that feature group. And then it is kind of consuming data from two different data pods, which are like tables. So this could be data coming from Neo4j, and then this data is making its way into Hopsworks. And then finally, we are training this model. So through this UI, through point and click, we can show you the full lineage, that how these calculations are done and where your data is coming from. Okay. So that's the lineage part. Now, let's say that you have already made the predictions, right? Now the predictions are made, your feature pipeline, your training pipeline, inference pipeline, all three pipelines are created. Now the job comes where you want to take actions. So we have a module which is called Business Rule Engine and Alert Management, which allows you to configure that functionality. So let's take a look at the business rules. Simple rule just for demonstration purpose here. Uh, you can see here, this is the business rule wizard. Here you can pick the data set. So I'm looking at all the predictions that were made within the Hopsworks platform, and then I'm saying like, I want to apply criteria saying check what is the possibilities around each of the prediction that is threshold, and then based on the threshold we are generating an overall score. The reason we are using the business rule engine so that we can combine multiple predictions into a single score and then take actions upon that score. Okay, so that's the business rule part. Now let's go into the alert generation. So now the rule is configured, the rule is executed. We have generated like a holistic score across all the suppliers that we are talking about for supply chain. And now I want to generate alert. So I can say I want to run a rule, which is basically creating an alert against this rule that was executed. And if the score is above 40, I would generate the alert. Then based on the value of the score category, so that you can prioritize them. When you're combining all the scores, you have various techniques that you can do averaging, you can do min max, you can also do normalization. So maybe your underlying model is doing generating scores which is like exceeding a value of 100, maybe it's like 200, 300. So what you can do is you can use the normalization technique, which will bring your score back into 0 to 100 range, and then based on that range you can apply the threshold to generate the alerts. Okay, so once the alerts are generated, then we can generate cases around it. Cases is basically a mechanism to triage your alerts. So we can definitely generate an alert and kind of kick a workflow. But then if you want to create a case, we can do that as well. We have a case management as a part of the tool. So here we are looking at the case management. This is basically on a supplier, which is 3603. This is the ID of the supplier, like a supplier ID. I can look at the entity details around this particular entity. So I'm looking at the supplier details right now. This data is coming from Hopsworks. Looking at this point, I can get straight into the case. So you can have more than one alert. Okay. And if I want, I can drill down into this alert as well. I can click on this alert, and I can look at the alert. I can look at the rules that was triggered as a part of this alert. So this is a rule I'm looking at. I can do some notes. I can attach documents. I can do notifications if required. Okay. Similarly, you can do the same features like doing the notes and the documents right on the case management itself. So this is where you can attach the documents. You can upload your documents over here. And then also you can kick a workflow. This is what I was talking about. So now, these features are not going to be available as part of ML platform, but by combining Infx and Hopsworks, we have brought together components for you to build your complete application, not just a feature or ML model, right? This is really the complete journey now, all the way from your source system to feature engineering to build a model, train it, and do the predictions and take actions upon it. So in this particular case, what we have done is we have created a workflow for one of our customers where we are initiating the alert that was generated as a part of the case. We are getting all the supplier details. Okay. Once we get the supplier details, then we kind of route that we assign this alert to one of the analysts. So the use case here is basically the credit risk analytics. We are trying to see that if a particular goes down, who's it going to influence factor, because that supplier may be doing a lot of shipping using that port, and then what's going to happen to the credit rating for that particular supplier or shipper. Okay, and then we can assign these alerts to uh, the respective people within the organization. Just inform the source system. And if you want, you can also assign humors within your application for various purposes. Check here on the, are there any more questions before I proceed?
No questions at this time, Yogesh. Please continue.
Okay, Nate, any questions?
There's no questions at this time, Yogesh. Your audio is breaking a little bit, just so you're aware.
So when you license the platform, you get platform. So what you do is you can take this workflow. The workflow engine comes as a part of the Infx license. When enterprise license, and then you can build it. That's available as a part of platform. Take a look at. Let me log in again. Let's take a look at like two last items now. I have two or three things. One is I'm going to show you how you can actually build a pipeline which allows you to stitch everything together. Like your feature pipeline, your training lines. While this is coming, hit on this. Okay. Okay. So while the pipeline screen is coming, I'm going to go over the dashboard. So these are the dashboards that you can build within the platform. So in this particular case, what we are saying is that, if a given port goes down, what is the impact? Like how many suppliers are going to get impacted? So as you can see, there are 200 plus suppliers who are going to get impacted. How many trade routes are going to get impacted? Because these 200 suppliers are shipping their goods to various ports, and these are the number of trades that are going to get impacted. And then we can see an overall impact score, like what percentage of these trades are getting impacted out of the total number of trades. And looks like there is a very heavy impact, which is like 95. So depending upon, you can do this what if analysis where you can change the filter. So I can say that instead of this particular, I can choose a different company and a different port. If that goes down, what happens? Okay. So this is how you can play with your data. And then you can look at which are the top 5 companies which are going to get impacted. So this is an idea I'm showing, but obviously if you have name within your data, you can do that as well. So that is where I was saying that you can store some supplementary columns along with your features that will help you to do better reporting on your data. We can very well take your data from Hopsworks, like the feature values, and we can join to the Neo4j where you have like a super set of data, and we can do all of these heterogeneous joins within the memory using Apache Spark and show you the results as well. So these are the top 5 affected suppliers. Similarly, you can see the top 5 affected trade routes. So you have these, the arrival and the departure, like how the shipments are moving between the source and target, and how much amount of trading is happening, and what are the number of trades that are taking place. So we can do this impact analysis, by creating a dashboard and visualization around it. Okay. So let me log in here. Yeah, I still have some issue on this. So I'm going to...
So Yogesh, while you're bringing that up, we have another question.
Okay.
How do we bring supply chain data in if it's static data? Can we also track supply chain loopholes and suggest fixes with the current models?
How can we bring the supply chain data with external data or?
So question number 1 is how do we bring static data from supply chain within supply chain in, right? Static supply chain data.
Okay.
And then number 2 is we also track supply chain loopholes and suggest fixes with the current models. How do we track that?
Yeah, for the
Sorry, Yogesh, you're breaking up a little bit on my end.
static data, either it could be in your database, it could be in your sources. Maybe you are availing to an external. Okay. Can you hear me?
It's breaking up a
Great.
little on my end still, Yogesh. Maybe you can repeat that answer just so that everybody can hear it again.
Today. Can you see my screen?
Yes, we can now. Maybe you can repeat the answer just so that we can hear you now.
Yes.
I
So
think
I
there was a
was,
little bit of a disturbance before.
yeah. So we are talking about the static data, right? So your static data can come in the form of a file. It could be within a database. It could be an API. So whatever maybe the source type, we can pull that data using the Infx platform within, depending upon what you want to do with that data. Databases, we can also bring data from APIs and flat files.
Thank you, Yogesh.
Okay. So I think the last part I was going to go through the pipelines. So let's look at a pipeline that's available within the system here. So I'm going to go into a development environment. Okay, and then the login. The last piece I want to show you really is the pipeline part, the data pipeline, and then we can take more questions if there are any. So there are 14 pipelines that are available here. Pipeline is basically an orchestration tool of all the steps that you want to perform. So in this particular case, we want to do like a supplier credit prediction, right? Like which suppliers are going to go for bad credit or is going to impact the credibility of the supplier because of the port going down. So if you see here, what are we doing is we are kind of taking the feature data that's from Neo4j. We are generating some features and we're pushing that data into Hopsworks. So that's really the first step where we are writing into the feature store. Then we are training the model. That is step number 2. So this is really the feature pipeline, the training pipeline, and the inference pipeline. These are the 3 steps that I was talking about. So what we do is rather than creating a spaghetti of code, we are kind of modularizing your application into 3 components, and then these 3 components are implemented within Hopsworks to make everything easy, and traceable. So the first component is the feature calculation. The second component is really the training of the model itself, and the third is the prediction part, which is nothing but the inference pipeline. Now you can do inferences in a form of a batch. If you have batch data, you can also use our API, which will allow you to do predictions in real time. It just depends what's your use case. In this particular example, we were able to achieve both. We could do batch as well as real time, depending upon what activity you're performing within your application. Okay, so switching back here. Yeah, so I'm going to wrap it up here. So let me give you a quick summary of what we went over today. So just to give you guys an idea, Hopsworks is a feature store. It's a machine learning platform which allows you to manage your features, build your features, do versioning, have scalability, and so on. It also allows you to do the machine learning development and these models using the open source libraries. And these libraries could be anything that's from scikit-learn to TensorFlow to LLM models, and all of this can be done at scale. So how it really benefits is like it's kind of reducing your cost, right? If you're reducing your cost, then you're having less mistakes within your application, and then you have better accuracy, because that's kind of giving you you're trying 2 targets in 1 bullet, right? We are reducing your cost, at the same time you are doing a better management of your application, which is improving your accuracy, which is nothing but reducing your false positive, right? And the better you are at making your predictions, like increasing the accuracy, the better you can market your products or take actions upon the prediction that are being made. So it kind of covers all 3 aspects that any enterprise would look for. Again, when it comes from in real time at a millisecond response time, a problem, we can take data in batch in real time. We can make predictions in real time, and we can also take care of things like data leakage, etc. Since Hopsworks is already aware of all the feature data within the platform, it could be possible that you are just trying to make a prediction. You don't have to send all of the feature values as a part of that prediction, because we are already aware what are the feature values, since the system is real time and it's up to date. So if you're implementing in a real time mode, that is a benefit you get, and everybody gets a very consistent view, right? Because everybody will be using the same API and the same version of features. So that kind of helps you to make your predictions faster, and faster time to value, which is basically using the low code accelerator, collaborating to build all your applications. And we are kind of, our job is to simplify your ML development, right? The overall ML development and deployment. It's not just development, because there are tools out there which are great at just building the model, but then you're kind of left in the middle of it, like what to do next. And then there's a lot of handshake between IT and business. There could be code rewriting. Again, that involves a lot of time, and there are chances of making mistakes or have a platform which is not scalable. So you don't have to worry about that. The platform is fully taking care of all the enterprise needs. Only thing you need to do is really get started on this platform and start building your applications. We have two options here to build your models. Either you can be, if you're a Python centric shop, your data scientist can use the Python APIs of Hopsworks, and they can do the feature engineering and the model development. If you are a low code development, if you don't have a lot of Python developers, then you can buy the accelerator, which allows you to make your life easy. You don't need to know a lot of coding, and also you can do auditability and traceability. Now you may have a lot of Python developers, and you may still want to use the accelerator, because now you can increase the efficiency of these data scientists, which can build more apps for you and do more experiments for you. Okay, so that's pretty much it. So Nate, back to you. If there are any questions, let me know, please.
Yes, Yogesh, there's one question. So the question is, are you able to track data lineage and provenance through from data through features to models?
Yes, I think I showed that. See where are they derived from. So we can show you where are they derived from. We can also show you what is the derivation logic for the same.
Great. That's the last question. Yogesh, thank you as always for your thrilling presentation on machine learning for supply chain systems using Neo4j features. If anybody has any additional questions or would like to reach out to us, my email address is nathan.greenhut@hopsworks.ai, or you can feel free to reach out to me on LinkedIn at Nathan Greenhut. Thank you for your time today, and we look forward to hosting you at future webinars and events.